Ladies and gentlemen, good afternoon and welcome to this session in the Hall 28H of the Trieste Convention Center. A special welcome also to people attending this session in the streaming. This session has been devoted to celebrate the innovation region in the framework of ESOF 2020 and in the section Breaking Frontiers in Science and Technology. We are making the point on Regione Friuli, Venezia, Giulia and MIT, enhancing excellence in science and technology transfer. MIT FVG project started 3 years ago. In the first year, in 2018, there were 8 projects funded. In 2019, 5, as well also in 2020. And today you will also have some news about the new call for new projects for 2021. It's a great pleasure to introduce on the podium Dr. Alessia Rosolén, Assessor for Work, Training, Education, Research, University and Family of Regione Friuli, Venezia, Giulia. Welcome. The assessor will give her speech in Italian language.
Yes, thank you very much. I apologize for arriving just now. I was there, I was looking at stands, so I speak in Italian because it's better to explain my point of view.
Sure.
And to explain the level in which region Friuli Venezia Giulia is moving herself from a long time ago. Grazie a tutti. Io colgo l'occasione di questa iniziativa, come ho fatto nelle altre occasioni, per cercare di fare il punto su quella che è l'azione politica, che è l'amministrazione regionale. Con iniziative come queste, ma anche con altre iniziative, con numerose altre iniziative e con numerosi altri partenariati ha cercato di costruire. Come ho detto anche in occasione di altri incontri, il passaggio dal globalismo al localismo in realtà è stato il passaggio che ha permesso di rafforzare e che permette di rafforzare anche in momenti come questo il ruolo della politica e della visione rispetto a quella che è l'effetto che si vuole ottenere da parte di tutti gli altri soggetti. La Regione Friuli Venezia Giulia per molti anni, per storia, per localizzazione geografica, è stata una regione che ha saputo utilizzare la scienza per andare a creare su questo territorio un humus importante di soggetti che dovevano consentire al nostro sistema sociale in primis, ma economico-produttivo, di fronteggiare quello che era il contesto internazionale nel quale andavamo ad inserirsi. Tutti i grandi soggetti che fanno ricerca su questo territorio sono nati e si sono insediati su questo territorio all'esito di un percorso complessivo molto lungo e molto difficile, che è stato l'esito della Seconda Guerra Mondiale, in cui un po' come si fa ora per rivitalizzare un'area come Porto Vecchio, si è scelto di utilizzare la scienza si è scelto di utilizzare scienza e ricerca come strumenti di visione. Ho già avuto modo di dirlo negli altri incontri, per molti anni in questa regione abbiamo avuto bisogno di confrontarci al nostro interno e di ogni tanto anche chiuderci nel nostro localismo per permettere a tutta una serie di soggetti di insediarsi e di costruire visioni. Dal 2008-2010 circa, e con amministrazioni completamente diverse, la Regione Friuli Venezia Giulia ha lavorato e lavora in maniera molto convinta rispetto a quello che viene ovviamente definito il grande processo dell'internazionalizzazione. Di solito la politica lo richiede alle aziende, alle imprese, ai territori e agli altri soggetti. In questo caso, come in altri casi, la politica della Regione Friuli Venezia Giulia ha scelto di essere soggetto attuatore di questo percorso di internazionalizzazione di un sistema che è il sistema della ricerca del Friuli Venezia Giulia. È un percorso lungo sul quale è opportuno lavorare, sul quale stiamo concentrando moltissime delle nostre risorse, ma sul quale stiamo definendo, e l'accordo con il MIT sicuramente è uno degli aspetti importanti, stiamo definendo quali sono i livelli di intervento del settore pubblico nei confronti di tutto il sistema della ricerca, quali sono gli asset sui quali ci possiamo muovere per dare strumenti a chi fa ricerca, a chi fa innovazione, per entrare all'interno di un mercato di nuovo globale e non, come è avvenuto per troppo tempo all'interno di questa regione, locale e finalizzato semplicemente alla costruzione del sé. E questo accordo col MIT è l'occasione, soprattutto con il suo rinnovo, e il rinnovo c'è stato solo perché il successo delle 3 annualità precedenti ci hanno permesso di poter valutare in maniera positiva le ricadute sul territorio, le ricadute su chi su questo territorio investe. Il dato è quello di andare a lavorare sulla ricerca applicata con le ricadute, e questo è un tema che non sto a spiegare a un pubblico, a un contesto come questo, perché lo conoscono sicuramente meglio di me. Ad andare ad identificare, e questo invece è un tema importante rispetto al nostro territorio, quali sono le tematiche di interesse del territorio del Friuli Venezia Giulia, e andare a instaurare una collaborazione duratura che in questi anni ha dato, attraverso tutta una serie di 3 selezioni annuali, tutta una serie di risposte a progetti nati e cresciuti sul nostro territorio per un percorso di internazionalizzazione e di visione che vada oltre i confini di questa regione. Parliamo di internazionalizzazione, parliamo sicuramente di collaborazioni che abbiamo instaurato grazie anche all'esistenza e alla creazione di un sistema di innovazione regionale che viene condotto. Parliamo sicuramente di visibilità, che è un altro degli aspetti sui quali credo la politica debba cominciare, mi sembrerebbe presuntuoso, debba sicuramente continuare a investire, perché visibilità non è visibilità per una delle opzioni politiche che in una situazione o nell'altra si ritrova ad essere alla guida della regione. Visibilità è visibilità di un territorio, delle nostre prospettive e soprattutto di una visione che noi abbiamo fatto nostra rispetto ai temi dell'Agenda 2030, ma che riteniamo essere effettivamente la parte di sfida comune di tutto questo percorso. All'interno di questo, ed è il dato finale sul quale io ritorno sempre, quindi creazione di un sistema, capacità di questo sistema di relazionarsi con quanto avviene al di fuori di questo territorio, capacità di dare visione a chi all'interno di questo territorio e di questo sistema lavora, capacità di immaginare, e questa è la sfida più grande per tutti quanti noi, quanto questo sistema di relazioni, ed è successo anche e soprattutto in epoca Covid, possa ritornare a fare di questo pezzo d'Europa sempre più centrale, che corrisponde alla regione Friuli Venezia Giulia, il luogo dove la sfida, dove il confronto, dove la visione guidano in realtà quel percorso di innovazione che, dico sempre, prima di essere di ricerca e scientifica è di innovazione sociale rispetto alle esigenze della popolazione. Io ovviamente non posso che ringraziare quanti hanno iniziato prima di me questo percorso con il MIT, non posso che ringraziare quanti ci hanno creduto, e non posso che ringraziare i funzionari che nella stesura del nuovo accordo hanno avuto la visione anche in questo, non solo di andare a cercare partner e soggetti importanti a livello di mondo più avanzato e mondo occidentale, ma hanno avuto la visione di comprendere che quanto siamo stati capaci di attrarre in 40 anni su questo territorio dai paesi, da molti paesi in via di sviluppo, dando opportunità di formazione, di accoglienza, di ricerca, debba in qualche modo essere indirizzato anche a loro. L'augurio, ovviamente, l'impegno di questa amministrazione è di procedere e di continuare in un percorso come questo. Lo stiamo facendo in moltissimi settori. Lo stiamo facendo, domani ne presenteremo un altro rispetto al tema della formazione permanente e questo sì della crescita e dell'innovazione sociale. Lo faremo sicuramente come l'abbiamo fatto col JRC e come in maniera coraggiosa e importante è stata fatta con il MIT, soprattutto se i risultati di questo percorso continueranno ad essere positivi e importanti come quelli che sono stati finora. Grazie.
Grazie, thanks a lot, Dr. Rosolin. Thank you. It's now time to connect with Boston, or better, Cambridge, Massachusetts, with Dr. Serenella Sferza. Good morning, Serenella.
Good morning, Gianluigi and all. It's a pleasure to be with you. I don't have a PowerPoint, so it's going to be just me and words.
I just introduced you.
Oh, yeah.
Sorry. Dr. Serenella Sferza is co-director of MIT Italy within MISTI, MIT International Science and Technology Initiative. Serenella, please, and thank you for being here.
I guess I was too eager to be with you, sort of, and so sorry for cutting you off, Gianluigi. Let me start by congratulating all the organizers of this ESOF conference, which I've been able to follow partly, unfortunately, remotely, because sort of, first of all, it was a fairly amazing feat, sort of, in the COVID area. But also, it seems to me that it was an especially important and necessary initiative at the time in which promoting the idea of science as a value system, as one of your keynote speakers said, and the key area of international and interdisciplinary collaboration seems especially necessary. Second, thanks for inviting me, and thanks to the president of Regione Friuli Venezia Giulia, the assessore Rosolin, the entire giunta, i rettori of the universities involved, Udine, Trieste, and SISSA, and all the staff that made the renewal and the extension of this agreement possible. Before going into discussing the agreement, let me say a couple of words, not so much about MIT, which is fairly familiar, I think, to all present, but to the part of MIT I represent. Together with Carlo Gatti, whom you may know because of his work on sensible cities and smart technologies and his numerous interventions sort of, on a variety of related subjects, I co-directed the MIT Italy program. This program is an official MIT program, which is part of the MIT International Science and Technology Initiatives. We have more than 20 programs located or that work with 20 different countries and or regions. And we see ourselves as bridges between MIT and the parts of the world that we work with. In my case, my goal is to bring more MIT to Italy, but also to bring more Italy and the best of Italy to MIT. And again, sort of, we see ourselves as a bridge that works two ways. Clearly, we are global, we are international, but we also see ourselves as promoting a variety of globalism that has very strong local roots. Sort of going back to what Assessor Rosolin said, we see ourselves as promoting glocalism. Knowledge is global, needs to travel, is even in the area of COVID, even more so now. But to bring positive results and to have an impact, it also has to have very strong local roots. And for me, this is, as of course, an institutional aspect, but also a personal aspect. I've said many times, my family, those of you who know me may already know it, but my family came from Trieste. I was the only one born in Milan, and now I live in Boston. So it's been, for me, a particular source of satisfaction and pleasure to manage to join those two parts of the world where my family had roots and where I now live. A couple of words about the MIT Italy program. Partly also with the agreement we have with Friuli Venezia Giulia, we're now one of the largest MISTI programs. We, every year in the past years, we have sent to Italy more than 160 MIT students and facilitated about 20 faculty research agreements per year. This is a fairly strong dimension and presence, and we're particularly proud of this because we have to compete for attention at MITs with programs like MIT China, MIT India, MIT Germany, and so forth. So we are particularly grateful to Friuli Venezia Giulia for being such a strong leg of our program. And this sort of we realize is also a very strong sign of the strength of the faculty that you have and the research you propose. Not to be too proud, but MIT faculty do not collaborate unless they want to. And it seems to me that the success of the funds that we have in the past and the collaboration that we have launched is a sign of the strength of what you propose and the research you are conducting. Briefly, to describe the broader context of which the Friuli Venezia Giulia is part of. The global seed funds, the Friuli Venezia Giulia agreement being one of them, are now present in more than 17 countries. Over the years, we have distributed more than $20 million to nearly 1,000 projects, and more than 600 MIT faculty have participated in these collaborations. MIT has about 1,000 faculty, so that's about 60% of our faculty who have participated in this agreement and have been involved in that. The amount of the individual grants is relatively small, $20,000, $30,000 average, but this is the spirit of this collaboration. We really see them as incubators for research ideas, but also very strongly research teams. Even in the global virtual world, research travel on legs, and legs sort of are linked to people, so people are needed for research collaboration. And so we really hope to start very soon to be able to travel again and to start again personal contacts and travel and exchanges that characterized those funds in the past. We're also very thrilled because there is a new focus on sustainability, very widely understood in the new agreement we have signed. And this is a theme that has become increasingly important at MIT. Just to mention, we have a MITI, in Italian is usually called MITE. It's the MIT Energy Initiative, which has served for a long time as a collector of research interest and a place where to bring together MIT faculty interested in anything related to energy, and it's groups a very strong number of researchers. And just to mention another aspect, there is an MIT center known as Poverty Lab, which has launched an entirely new way to assess the effectiveness of policies in developing countries. There are two founders who have recently won in last year the Nobel Prizes in, or have shared the Nobel Prize in economics. So that should also serve as a magnet for new initiatives. So I'm really looking forward to the expansion of the teams to include sustainability more fully, and also to include new centers of innovation on the Friuli Venezia Giulia, which is so rich of such initiatives, like the synchrotron and the oceanography research centers and others. Assessment of past projects. We're still, I think, we still have to see the full impact of what has been done, partly because academic research, even at the most effective level, has its own timing that tend to be a little bit long. And also partly because the last research funded has basically been interrupted by COVID. And again, we hope to see the projects start full speed again in the spring. Based on what I've heard from MIT faculty involved, MIT students involved, the feedback has been very positive. I know that some of you have hosted MIT students, sometimes in the context of the shared research with MIT faculty, and the feedback has been more than enthusiastic. So I really look forward to the continuation of this agreement. I look forward to the new projects that will be submitted. And I also look forward at serving as a bridge whenever possible between faculty from your institutions and MIT faculty. I just want to end with a reminder. Sort of the deadline for presenting online collaboration projects this year is September 14th. And the deadline for submitting the proposals is December 14th. We have postponed the cycle due to COVID, but I mean, to leave more time for faculty to get together and to propose projects. But again, contact me in case you had any question, and I'll be happy to help you. And if there are questions and answers, I'll be equally happy to address them. And thanks again to the region and all the universities and participating research institutions for participating in this agreement and extending it, and looking forward to work with you and meet you in person. Thank you.
Thanks, Serenella. Now I would like to introduce Dr. Saratesi, coordinator of Friuli Venezia Giulia office in Bruxelles. Until March 2020, she's been coordinator of the Unit for Cooperation, Development and International Partnership, and in this framework she took care of the agreement. Thank you, Sara.
Thank you, Professor Rozza. It's a great pleasure for me to be present today, representing the International Relations and European Programming Office of Friuli Venezia Giulia, and also representing my director, Sandra Sodini, who is connected in streaming. While we are honored to present the results of the multi-annual cooperation with MIT, I am keen to point out that the regional support recognizes the hard work of our regional universities with an active role in international and international and European level in the area of research and innovation. So I would like to express my gratitude to all the team, to SISSA, Udine and Trieste universities, and also to Professor Sferza, who is a pillar of this team. Science and technology transfer are part of a common language that should unify people and nations. Higher education and research shape future generations and are critical to a sustainable growth. The future of Europe is strictly connected to the power of innovation. European regions, as Friuli, Venezia, Giulia, should contribute to this process as an active partner of the European strategy for the next programming period. As already expressed during these days, Friuli, Venezia, Giulia is a small region, but with a great potential and an essential role for the European performance in research and innovation. I would like also to remark the strong commitment of our regional government, represented today by Ms. Alessia Rosolén, in the framework of the European Smart Specialization Strategy, stressing the importance of some strategic sectors, such as smart health, biotech, advanced manufacturing, domotic, creative business, being an active partner in the European platforms for smart specialization strategies in Europe. Even if the current pandemic crisis has led to an extraordinary situation, both in terms of priorities, health systems, employment, credit crunch, and socioeconomic values, the promotion of international innovative partnerships remain one of the regional priorities. The recent World Bank's forecast presents a global situation even worse than expected for the Eurozone's GDP. This situation requires a special resilience and a prompt action with a strong regional approach. European regions are the place where universities, research and innovation centers, technology transfer organizations, and enterprises are based and supported, and where the added value could be generated. Being part of the Friuli Venezia Giulia MIT program allows our regional universities and our system to participate actively in our international cooperation efforts towards the creation of a strong research and innovation regional ecosystem and new value chains that are now essential for a sustainable renaissance. Many challenges as health and aging, energy security, global warming are not unique to one part of the world. They affect all of us, we know. And while other challenges can seem more local or regional, sooner or later they will cross boundaries and have widespread impacts, like the effects of climate change, environmental problems, or the increasing scarcity of critical raw materials. That's why we need more international cooperation to address better these challenges, to deliver results for citizens in the European Union, United States, and worldwide. Only an integrated approach could lead our regions and countries as a whole out of the crisis. It makes sense to pool resources in common areas of interest in order to increase the impact of research, set standards, promote breakthroughs, and boost our ability to face the crisis. We should adopt an even more comprehensive and systematic approach. And for Friuli Venezia Giulia, this includes fostering skills that are essential for more resilient economies and more inclusive societies, supporting the technology transfer to our enterprises and the capitalization of research results in our local dimension. Friuli Venezia Giulia would like to continue supporting the integration of research and productive and social development. We are aware that economic growth and innovation are closely linked to local conditions, where key driving factors are industry, science, and academia in a complex interaction. But we are also aware of the importance of developing cross-border and international relations. You have heard about Friuli Venezia Giulia a strategic European region at the crossroads of major transportation routes and distinguished for its multicultural and economic dynamism. The region, and in particular the city of Trieste, has been and remains a bridge between Western and Eastern Europe and a platform towards Central Europe and the Southeast Europe. Our role towards the Western Balkans is a strategic tool in building alliances and partnerships, thanks to our particular autonomy in concluding international agreements. In many occasions, the international relations of Friuli Venezia Giulia played a central role in the international scenario in order to contribute to the stability of this area and to provide a hub for building up new connections for the cross-border and transnational cooperation of Central and Southeast Europe. Thanks to our heritage of relations, in 2000 we were one of the first Italian regions approving a specific law for promoting international partnerships and development cooperation. Through this regional legislative framework, with a multi-annual program setting geographical and strategic priorities, we had the possibility in 2017 to start the cooperation with MIT. This initiative demonstrates that for our region, science diplomacy is considered as an essential element for supporting strong international partnerships, promoting our regional ecosystem. Higher education and research will be important for the sake of our young people, for our economy, and for the quality of our industrial production. We need more investments focused on international cooperation, on people and knowledge transfer. The Friuli Venezia Giulia MIT initiative has already achieved remarkable results since its launch, but we think that this is only the beginning of an exciting journey. Many opportunities, especially in relation to the Agenda 2030, remain to be seized. We have a proficient cooperation with the UN system through its specialized agencies and other international organizations implementing specific programs related to the SDGs as defined in the agenda. Our region fully recognizes that international cooperation will be fundamental in achieving the goal of implementing the global agenda. And for this point of view, MIT could be an essential partner. And for this reason, we signed this year a new agreement with MIT with the aim to increase the impact of the cooperation in line with the SDGs. The new agreement supports, in fact, research projects, including themes as economic inclusion and diversity, environmental protection, and a fair and peaceful institutional setting. So strong international cooperation is needed now more than ever to ensure our countries have the means to recover from the pandemic, build back better, and achieve a sustainable development of our planet. Friuli Venezia Giulia and MIT are committed to do it, and so thank you for inviting me.
We have now greetings from Professor Stefano Ruffo, SISSA Director, International School for Advanced Studies, Trieste, also on behalf of the rectors of Friuli Venezia Giulia universities. Professor Ruffo is also a grant holder from FVG MIT initiative, and at the end I think that he will say also something about his quantum computing project. Welcome, Professor Ruffo, and please. We cannot hear you at the moment. At the moment we have no audio. Do you think that it's possible
Unmute.
to... Okay.
Now you should hear me.
Perfect. Apologize and thanks for being here.
Okay, so I start sharing again. Okay, so it's really a pleasure. Good afternoon, everybody, to be here. And first of all, I thank the regional government for promoting this agreement that was very important for the research going on in universities. I might, before talking about my project, I would like to make a few comments about the fact that the Italian system is somewhat patchy in the quality of the research. So in Italy, we say macchia di leopardo. And the excellence is spread everywhere and in all departments, and sometimes it is hidden. And I think in order to recognize the value of the research activity, it's very important to be pointed out from outside. So I think this is one character of this project, which is very important. So the fact that anybody in any one of the three universities of the region is allowed to apply for the grant and then to be evaluated by a very high level commission. And the fact of being then selected is a recognition of the quality of the research that they do. So that was my first comment. And the other comment that I would like to make is the fact that it's very important that the region and anywhere at all levels, not only at the regional level, but also at the national level, that there is an external evaluation. So we know that our papers are evaluated by peer review at the international level, but we also need for the selection of the projects, that research project, that there is a really a very strong external committees that select from outside. And I think that it's undoubted the fact that the faculty of MIT and all the referees that they have around them can provide really important evaluation and serious evaluation of the research projects. And another aspect that I would like to make is another comment. The third one, and before going to my project, is the fact that the importance of basic research. I've had today the talk, a very beautiful talk of Ada Ionat from Weizmann, and her research about ribosomes that brought to the devising new antibiotics, and that was really on a very short time. So it's very impressive that how fast one can go from basic research to applications nowadays. So although the nature of this project is not the one of being involved directly in the applications, I'm pretty sure that many of these projects will lead to important applications. Now, let me come to my project. So I take the opportunity to speak about science since I'm the director of SISSA since 5 years. It's very rare the opportunities for me to talk about science. So I'm very happy to do it here. So what's my project? My project is around an idea that combines quantum mechanics with thermodynamics. So it's a very, very interesting combination, because one has the idea that thermodynamics has to do with fluids, with macroscopic systems, but there is also a thermodynamics of the small systems. And that had a very important development in the last, let's say, 15 to 20 years. And one of the most relevant results happening in this field of thermodynamics of small systems is the fact that one can formulate thermodynamic laws on the basis of equality. So you know that the statement that entropy cannot decrease. So it means that entropy of the universe and of the system that you have isolated is a quantity that absolutely larger or equal to zero only when and it equals zero only when the process is reversible, which never happens in nature. Entropy is which is a concept which is very difficult to define, but everybody speaks about entropy, and so you have a basic feeling of what is entropy. Expresses the second principle of thermodynamics in the terms of an inequality. But then in the last years emerged the possibility to formulate thermodynamic laws as equalities. And one of the most known equalities was the one found by Chris Jadlinski, and has to do with the fluctuations of energy exchange. So when you have you are interacting with the system, you are exchanging energy with the system. Now, at the quantum level, now comes to the second. Besides producing energy changes by interacting with the system, so with an instrument to the system, you also produce energy changes when you do a measurement. So it's very important to understand this process of any energy exchange when you do a sequence of measurements. And that's the core of the project. So to find a system for which one can understand the principles of...
Professor Ruffo, sorry interrupting. We are not seeing transition in the slides.
No, because I'm already at the first slide. So
okay.
So I'm still in the first slide.
Okay.
So this is part of a collaboration that I have with Paola Cappellaro at MIT and this group, David Layden and Pai Peng, and the quantum engineering group, and my small group at SISSA, and Andrea Trombettoni is a CNR researcher and is now at the University of Trieste, and Guido Giachetti, who is now a student, a PhD student at SISSA, and Stefano Gherardini in Florence. So can you see the transition now? Okay.
Yes.
So the idea is to find a system that, a small quantum system in which you can have energy exchanges. And the system is the defect in diamond. So defects in diamond are created when diamond grows. And there is a typical and specific defect, which is called energy center. And you can think of this defect as sort of a particle in the middle of a crystal, which is the diamond. And this particle has a magnetic moment. And this magnetic moment reacts to very, very small magnetic fields. So it can react to magnetic fields that are of the order of 100,000 smaller than the magnetic field of the Earth, the one that, for instance, orient a compass when you go on a walk with the compass. So, so it's a very small field. So you can imagine that if an electron will be at a distance of a few hundreds of nanometers, it will be felt by this rotating magnetic moment. So moreover, this rotation of this magnetic moment is very coherent. So it can be used in a quantum sensing and quantum computing device. So what's the idea? The idea is to use a set of such defects as a computer. And now the computer becomes a machine, and this machine exchanges energy with the environment. And we would like to understand how the energy with the environment is exchanged. So just to show you that I'm not speaking in vain, so I can tell you that we have already 3 publications. The project started was one of the projects selected in 2019, and we have already 3 publications. One, the last one appeared very recently in Physical Review Letters by the MIT group. And we already did 2 visits, one of the SISSA group to MIT in April, May 2019. And then we had a visit from MIT. And of course, the 2020 visits have been postponed due to coronavirus. which are the main results for the moment? The main results, we have tested already these fluctuations relations on experiments, and we are now generalizing these equalities to more complicated settings, and we plan to go on with the experiments, and one day perhaps to give our contribution to the field of quantum communication, quantum computation, and quantum sensing, which are very important fields for applications and for communication. So I finish here my talk.
The idea is to continue on providing some example of projects and also their potential impact on scientific advancements, but also on the territory, and also in the effort of creating synergies between several institutions. So now I call on the podium Professor Giorgio Sulligoi, Professor of Electronic Systems from University of Trieste. Thanks, Giorgio.
Thank you. Good afternoon, ladies and gentlemen. Okay. My name is Giorgio Sulligoi. I'm Professor of Electric Power Generation and Control Systems at the University of Trieste, where I work basically with my research team at the ETF on mainly everything is related to the transfer of electrical power from each kind of grids, land-based, to each kind of vehicles, and in particular, as you see in the sketch, marine vehicles and marine systems. We are operating with some series of partnerships, both in the academic world, in the industry, and in the public administration sector. And first of all, I'd like to thank for this invitation the Regione FVG and SISSA Giulia, so Dr. Rosolén and of course Professor Rozza for having invited me. And we've been invited, I was asked to try to propose the origin of a successful proposal to the MISTI program, to present some results of this project, which I will do very briefly, because I'd remember these MISTI projects are rather fast and small projects. They are like some kind of seeds. So we are funded to get in touch with the researchers from Italy and from MIT, and to, in a way, revise, write down, revise some results, and write down also further proposals for further funding. And in this sense, then I will try to concentrate a little bit more on the impacts on our territory and possible synergies with industry and industry research and development organizations that actually came out our project that is entitled Green Ship Design, Reducing Ships' Energy Footprint from Early Stage. To get there, let me just be a little bit autobiographical, but it is to mention a property that, in my opinion, is fundamental to get some results, that is passion. Passion for science and passion for technology in a given area. Personally speaking, this part of this route starts from my final project at the MS in Electrical Engineering in the University of Trieste. University of Trieste had a long tradition. My professor, Giovanni Giadrossi, was among people who already many years ago was studying electric generator modeling and ship system, electrical system stability for ships, in particular for big ships, like the one that are built here in our territory, in our district, from Fincantieri and with all the collaborating companies. And actually, this thesis was done after an internship made in the electrical and automation office of Fincantieri Cruise division here in Trieste. My co-supervisor was Dr. Darin, that at that time was the in chair of the research of the R&D for the electrical office. What is this? This is the sketch of an entire, let's say, principal distribution electrical system of a cruise ship. This is, let's say, belongs to almost 20 years ago. It's from Ocean Princess ship. Perhaps some of you may have taken any cruise on that ship, a beautiful ship. This is a kind of zoom and shows a little bit how the electrical engineering and research is called to work, because here you have a lot of power generation. You can find almost every type of electrical and power electronic device and system, a lot of control system, and so on. Big electrical propulsion motors to move these giant ships, and so on. To give you an idea of the complexity of such systems, one of the recent built ships by Fincantieri, that is Royal Princess, has something like 4,000 kilometers of electrical cables on board, something like 20,000 channels of automation, 20,000 switch gears, and so on. So it is a huge complexity that has to be controlled, managed in real time, and that required very, let's say, deep and robust techniques for the design, because nobody can afford to do some mistakes in the design of such complex systems, such complex ships. Here, after my PhD, I came back to Trieste. I spent my PhD between Padua, Milan, and the Ireland. I came back for, let's say, this initiative. I think that RINAVE Consortium was the very first organization that was set up in this region to convey efforts on research on marine systems and naval architecture, making regular calls for very, very specific arguments. And so we were able to get one of these very, very first calls. At that time, I was between postdoc and becoming assistant professor at the University of Trieste, so I was able to get one of these proposals, and then to get some funds, some people, some instruments, and also to travel a little bit, and to attend this, that was, and still is, in my opinion, the leading conference in the world on electric ship technologies. I would like to underline this because sometime today, also, I say to young researchers, we are very, very pushed to produce research results, to be in the journals, and so on. But remember that attending the right conference is absolutely not a waste of time. In my opinion, the people that you see in this committee were extraordinary people. They were actually the most expert in the world in the field of electric ship technologies. After 15 years, some of these have become colleagues or even friends. We have been working with many of them. After a couple of years, the organization of this conference asked us to give an invited speech there, because they had nobody able to speak about the big electrical cruise ships. And so we proposed Mr. Darin, my co-supervisor of my final thesis. He went there, gave this invited speech, and at the same time, we were able to get an award at that conference. This was an outstanding paper award that we got for a working collaboration with the industry, with in particular Ansaldo and Nidec Ansaldo, what is now named Nidec Ansaldo here in Monfalcone, for some special prototypes of ultra-fast and ultra-light generators for power generation on board. And that was for us a signal to say that we were in a way able to give something with respect to the state of the art. So after some years we had understood some parts, and we were able, we had the confidence that we could be able to give something. This is just a picture. That's myself on my right. The first guy is my co-supervisor. The guy in the middle, I don't know if anybody of you knows him, is Professor Ned Mohan. That is one of the guru of the mice in power electronics. My textbooks was actually, and for generation of engineers, the Mohan. He was attending the same conference, just relating to the fact that attending a conference can be a waste of time. He was there attending our conference. We had the opportunity of having some great exchange with him. After some years, there was the start here of the first naval district that then became the maritime cluster. And so again, the region of Friuli-Venezia Giulia continued to invest on this topic and to organize and to fund in an organized way the research. This was a big project. At that time, we got €1 million in partnership with Fincantieri as a lead partner and Polytechnic of Milan, as you can see. And Trieste was the scientific leader there. And after some years, I was invited in the committee of ESTS. And that year, you see this guy in the square, Professor Chrysostomidis from MIT, was one of the general chairs. So we got in touch. After a couple of years, there was the signature of the MISTI agreement from Regione Friuli-Venezia Giulia and MIT. And so for us, was in a way natural to try to write down a proposal. The proposal was related to something concerning very complex problems in the early stage design of the ships. And as you see, it was 2017. It was the first call of the MISTI for Friuli-Venezia Giulia. The project is related to, let's say, moves from the fact that early stage design choices are very, very important because they predetermine the effectiveness of the overall design of the ship, and in particular the effectiveness and the impact of new electrical technologies. So we are full of electrical technologies, new, such as batteries, such as storage systems, power electronics, and so on. But it is not easy to insert them into a new project, to a new building of a ship, in order to then prove what are the advantages that these new technologies can bring. If we are able to do that in the very, very first stage of the design project, of the design process, this is the design process of a big ship, of a complex ship. So we are between that concept and preliminary, just to say. This can be very valuable because it reduced the risk and made it possible to show to the ship owner the property of the ship in very advance, and brings you, okay, of course, an evident advantage in terms of competitiveness. The project was organized on different work packages. From the proof of this concept, for instance, the power corridor is a modular architecture invented by MIT. Other packages more related to naval architecture. Another one, this one is more on the integrated ship design, so how to leverage on most modern compute-based ship design tools to prove and quantify these advantages that was referring before. It is something very, very close because we talk about parametric three-dimensional ship models, so kind of virtual prototypes. It's not far from the so-called digital twins, which is something important also for them making some live demos and some initiatives of tech transfer here in Friuli-Venezia Giulia. I didn't say the team is multidisciplinary. There are one team of electrical engineers from University of Trieste, another one from marine engineer, and another one from SISSA about calculus and analysis, because the application of these methods can give you thousands or tens of thousands of solutions feasible, so you need also to be rapid and to get automated algorithms in order to take out the 10 or 5 or 3 best solutions from the first mass, the first space. So working on, for instance, reduction of parameter space was very important with SISSA. And the final package was to put everything together in a kind of decision support system in order to give the advice to the designers, to the ship designers. These are some results in terms of exchanging of people. Just to say that one undergraduate student from MIT has spent a couple of months here in Trieste in our lab during the summer, and assistant professor Vittorio Bucci from Trieste Marine Engineering spent a couple of months in Boston at the Sea Grant. This is about some publications, some results. Last thing I want to say regards a project that is synergic, that also came out some of the discussions made between ourselves between the researchers of MIT and other officers from Fincantieri and from Wärtsilä here in Trieste. That is this one, the ETF project. You see the partnership more or less is the same. The ETF project is devoted to build a demonstrator of electric ship technologies in real scale. This will be built, it is being built actually in this month here in Trieste at the Wärtsilä premises. And I would like to say, if we reason in terms of the technology readiness level, that our studies made with MIT colleagues are in the low levels, I would say TRL 1 to 3. Then we want to use this ETF demonstrator here in Trieste to scale up from 4 to 6, and then the final part of the roadmap should be to start building through ships and integrate techniques and tools in complex electric ships production. My conclusions is that, first of all, to get a kind of success proposal, you need to study. So you need years of studies and attending the right conference and the right people to understand state of the art and produce the first research results. Then if you want to do science to business, which is one of the aim of this ESOF this year, it is also important to understand the industry value chain so that the ideas from the researchers can go in the rings of the value chains that has much more value, and so can be evaluated and implemented. Our context, at least for the maritime technology, is a context very rich, so it helped. Without our context, our district, the Fincantieri, the region, the contributions, the Rinave, and so on, we wouldn't be able to organize such a group. You need personal effort and passion, a great team. I must thank our team of engineers, both from the school, in particular University of Trieste in electrical and in marine engineering. And if you get there, then the MISTI FVG is, of course, a formidable instrument to share ideas and scale their results impacting worldwide. You can say that it's kind of instruments that you can use and say you can reach whatever target you want. Thank you very much.
Thank you, Professor Sulligoi. During the transition, since we are a bit over time, I kindly ask if you can contain the next presentation in 7 minutes. Otherwise, I ask confirmation till when the streaming is going on. It's a great pleasure also to introduce now Professor Davide Seni, the Professor of Electronics at the University of Udine.
Okay, thank you very much for giving me the opportunity to discuss about our project in the framework of the MIT Friuli Venezia Giulia project. And to introduce the framework of our project, I just would like to show you this sort of iconic image of Steve Jobs that actually back in 2007 introduced one of the first models of the iPhones. These were the first, let's say, wireless computers with very many sensors. Those devices that nowadays populate what we call the edge as opposed to the cloud. So all the portable devices that we all have in our pockets. When you think about information technologies, which are extremely pervasive nowadays, everybody knows how pervasive they are, okay, even too much, even a little bit intrusive more than pervasive. In fact, you don't think about energy efficiency, but energy efficiency is instead an important point for information technologies, because in fact, these technologies dissipate a huge amount of energy, much more than people may in fact think. And this has been made even worse, in a sense, by the explosion of artificial intelligence. And the artificial intelligence actually emphasizes the importance of energy efficiency for information technologies. The way this typically works is that we collect the data at the edge here in our portable devices, and then anytime some sort of significant artificial intelligence task is needed, data are sent back to the cloud, which is inherently, energy inefficient itself, because communications are quite inefficient. And then everything is actually calculated in the cloud, and then is sent back to the edge. In the cloud, you do have the energy, but still energy is a problem because you consume a huge amount of energy. At the edge, you have just a little bit of energy, and so it is at the edge that the energy efficiency is particularly critical, I would say, for edge artificial intelligence. So actually, the energy efficiency, as I said, is important for portable devices. We know that. It's the lifetime of our cellular phones, right? That frequently at 3 p.m. run out of battery. And it's important also for those systems that we call energy autonomous systems. These are some that, for instance, sensor networks, some devices that are supposed to harvest the energy they actually need from the environment. But it is also important in data centers where the energy is there because devices are plugged in. But again, they really consume a huge amount of energy. It's an estimate that about 10% of the worldwide energy consumption is in information technologies. And so the nano-electronic technologies, mainly still today silicon-based, are the hardware platform for the information technologies, and the digital circuits essentially switch packets of charge. So in order to reduce the energy, you need to reduce the charge and reduce the supply voltage. And this was essentially what our project was about. The project, the PI in Udine is me, of course. We had a PhD student who's been very much involved in the project, Tommaso Rollo, and the PI at MIT was Luca Daniel. And the goal of the project, that's the title, the goal of the project was actually to develop models for some special devices, ferroelectric materials-based devices, in order to enable particularly low voltage and consequently low energy operation. So when Gianluigi asked me to think about synergies and implications for the Friuli Venezia Giulia territory of our project, I thought about some examples. I have 3 examples, and I hope that you will also think this as relevant for our territory. Last year, actually, really, in these days, last year, at Udine, we hosted a very much international conference, and there was a presentation from this project. And the PI from MIT came over for the conference, and also there was a tutorial at the conference that was arranged in collaboration between the University of Udine and the SISSA Trieste, so this is sort of a small seed of a collaboration that I'm very much in favor of. And this is definitely an example of something that had a synergy with, in my opinion, commendable initiative in our territory. Another thing that I want to mention that I think is important is that actually Tommaso Rollo, the PhD student who was involved in the project, is now employed here, essentially half an hour from here, in the Thundernil SRL. And it's essentially a high technology, high-tech company whose core business is nanofabrication in collaboration with the Synchrotrone. And honestly, I think that the employment of highly educated young people in high-tech companies in our territory is in fact a major goal that our university system should in fact pursue. I'm very much in favor of internationalization, but still, of course, this is also an important goal. The last thing that I would like to mention as an example is that the topics of the project continued in our group, even in a postdoc of the former PhD student, and now also with our PhD students. And these ferroelectric material-based devices allowed us to be part of a European Union-funded H2020 project that is very important for our group, of course, and then also for our institute. And this brings me to the last thing that I would like to mention. I mean, the ultimate goal of this Biferosynaptic project is to develop technology platform based, on these special, let's say, devices, to demonstrate an extremely energy efficient neuromorphic computing architectures, particularly suitable for edge artificial intelligence applications. And that's my last slide, where I would like to mention that it's really a special time, a particularly important time for physical devices and algorithms for neuromorphic computing and artificial intelligence. We're starting understanding that our brains are vastly different compared to human-made computer systems in several respects, and even energy-wise. Again, okay, I don't want to read the figures here, but you see how much energy it takes to train a state-of-the-art, let's say, neural network for natural language processing. It's a huge amount of energy. It's what our brain consumes in 6 years for all the tasks it's supposed to accomplish, okay? And so the brains are nowadays, and computers are vastly different, both in algorithms and in physical implementation. And because I'm here just in front of, decision makers and politicians, I would like to say that there's a new era for computing artificial intelligence that is coming up, that has come up already, in fact. And it has actually huge implications, not only technical, but also ethical and societal. And it's a huge challenge, but also a huge opportunity also for the educational system and for the scientific importance. I really would like to have initiatives here in our territory, okay, with this goal. I just would like to conclude by saying that the MIT, that is well-known, let's say, far-looking institute, in fact, has taken this challenge with this College of Computing that's been recently funded, and it is definitely a commendable initiative.
Thanks, Professor. Thank you, David. We introduce now still Mr. Federico Picchi, a doctor in a few days, from SISSA, Mathematical Analysis, Modeling and Application PhD program. Please, Federico.
So, good afternoon to everybody. I am Federico Picchi, a PhD student in mathematics at SISSA, and today I will present the project ROM2S, Reduced Order Methods at MIT and SISSA, which allowed us to work with the co-director of the Computational Engineering Department at MIT, Professor Anthony Patera. So, the leading motivation of our project was the need of many query and real-time simulations for complex parameterized problems, coming from, say, for example, industrial or clinical applications. Where, let us consider, for example, the buckling of a plate or the blood flow in the heart chambers, or, for example, the compression of a beam. Well, we are surrounded by these phenomena every day in our life, and a strategic task for the progress is to, develop a deep understanding of their complex behavior. Well, all the phenomena that I've mentioned can be, modeled through the so-called partial differential equations, but thinking about how differently, a rubber object responds to a compression with respect to a steel one, well, it is clear that the the model, then the model analysis has to carry out some information about the physical properties, or about their physical properties. So this goal is achieved by employing a parameter dependence of the equation, and this led to the aforementioned need of a many query context, efficient many query context, in order to, obtain fast evaluation of the models. And as we will see in a few seconds, the key aspect of this method is the combination between high-performance computing resources and the reduced order models methodology. So let's start from the latter, with really few words. The goal of reduced order models is to, enable efficient evaluation, really fast evaluation for some models which usually requires also even impracticable computational costs. And this goal is achieved by, employing a computational, the computational offline-online paradigm, which splits the simulation into two phases. During an offline phase, one, can perform using these HPC facilities a science-driven and a time-demanding investigation of the parameter space, while during the online phase, one, follow the routes guided by the industrial needs and obtain in an efficient way the solution and the simulation at each new instance of the parameter. So, to enable this, one of course need the parameter space investigation, but also the efficient assembly of the high order, by means the huge data structure that are coming from the numerical approximation. Well, a pipeline, ideal pipeline is I have the parameter dependent partial differential equation, then I perform the expensive process, so called the full order approximation, and then I rely on the quantities that I have pre-computed during the offline phase, so with high performance computing and all the supercomputer in, an efficient way at each instance of the parameter. Translating this with images, it's like we are dealing with the big red square, and we try to decompose this analysis studying the little green one, and this is this is fine because these new green square are independent from the parameter, and their dimension is much lower than the dimension of the huge data structure that one wants to pre-compute offline. Another thing very important is that once from the, high performance computing point of view, we need grid resources. From the online point of view, we just need, I don't know, really, even low CPU devices like, smartphone or tablet, or even a dedicated web server like the one that we are developing in our group. So, having presented the methodologies, let's talk about the application. My application is bifurcating phenomena at large. So these involve the sudden changes of the behavior of the solution and their properties. Here, the main focus is how the bifurcation, deals with the physics. And here I present three different applications to physics, from continuum mechanics to fluid dynamics and quantum mechanics. The real problem in bifurcating systems is the lack of uniqueness of the solution. So even fixing the parameter, you don't know which solution the system could attain. But the focus of this project was the applicability, the study of the applicability of reduced order models to bifurcating phenomena in computational mechanics and structural components. On the left and on the right, we have the von Karman plate equation and, respectively, the hyperelastic models for buckling. We study 2D and 3D objects On the left, in both cases, we have interest from industry on the left to naval companies, and on the right, in the Norwegian petroleum industry. They are essentially interested in the buckling of this object, because this could this could lead to the failure of their components, and so they are interested in the first buckling that is strictly linked with the bifurcation analysis. And let me just finish by some final observation. I would mention the importance of the industrial PhD scholarship, and the also the collaboration between from the universities and industry, also towards new technologies like the digital twin technology. Then, as concerns the methodology, we can think to combine emerging technologies like artificial intelligence or machine learning to the reliable mathematical methods. And finally, I want to greatly thank the Friuli Venezia Giulia region, MIT and MISTI for this unique opportunity to create new collaboration, and also with other top universities that are fundamental, I think, for young researchers. Thanks.
Thank you, Federico. So we leave now a final speech to Dr. Sara Guttiglia, Area Science Park, General Coordinator for IP for FVG, Strategic Asset of Argo System. Thank you, Sara.
So, good afternoon, everybody. My name is Sara Guttiglia, and I'm great to be here this evening representing Area Science Park. Thank you for inviting me. Thank you for the region for organizing this important meeting. And I will try to wrap up the conclusions of this afternoon. So let me start explaining why Area Science Park is represented here this evening. So as it has been said, the program FVG Meet Italy Seed Fund facilitates scientific exchanges between MIT and the regional universities. But the program started in 2017, but it was renewed, as it was said, in 2020. And also the research institutions of the Scientific and Innovation System, SISSA, were included into this collaboration. So thanks to the region for having thought about also this inclusion, which is very fruitful for us and very strategic. As you can see, the system is very complex, and there are a lot of partners, and each of them can contribute to expand the reach of the collaboration and valorize the research impact in the region. And in fact, how can Area Science Park contribute to such an amazing program? So Area is considered to be a meeting point between research, innovation, and economic development. At Argo, which is led by Area, through the contribution of the Regione Friuli Venezia Giulia, the Ministry of Research and the Ministry of Economic Development, was set up 3 years ago in 2018, and is funded on 4 assets that are diverse between each other, but they are also part of a complex system. So the 4 assets are innovative industrial segments, then there is another asset on new business creation, another asset on process innovation, and another on technology platforms and open labs. So it is a complex innovation system which is based on research and on innovation, and the final goal is to enhance the economic growth and the development on the regional territory. How this Sistema Argo and MIT can find a type of collaboration. This can be seen just speaking about the collaboration, that the collaboration with MIT can boost the quality and the impact of the existing networks. Therefore, selected MISTI collaborations can be used for such a goal. And in particular, it is important to underline that usually these projects are funded just to start a collaboration between the universities of the Friuli Venezia Giulia and the counterpart in MIT. So they last 1 year, 1 year and a half, and they are seen as a mean to start to work together. But then, as a request also of the final reports that all the researcher has to fill in, there is a question which regards the way how the research can be furtherly expanded and funded. So I'll try to give some examples on how Area Science Park and Sistema Argo can contribute to this. For example, the technology platforms and open labs asset of Argo is composed by 3 open lab systems. One is very well known, which is, of course, Elettrasynchrotrone. And then we have genomics and epigenomics platform and structural biology platforms. All this is supported by a data center and HPC facilities, which were built in the last years, and through the financement, as we said, of the region and the ministries of research and of economic development. We have already 12 partners, more than 20 research institutes collaborating, and so far more than 130 requests for companies to use these platforms. But it's nice to see that in just some months ago, during the summer, Area and Argo launched 2 fast-track calls to start, to contribute fighting COVID-19. And in this case, we directly financed projects with the target on genomics, both for enterprises and the research universities. So this could be a way how the project that have been started through the MIT collaborations of MISTI can find a follow-up here on the territory. Another asset that can be used as an example is the process innovation asset, which is industry platform for FVG. This platform accounts for technological nodes which are spread around the regional territory. These nodes are technologically characterized. So one is on Internet of Things, one on data analytics and artificial intelligence, one on data optimization and simulation, and one on advanced manufacturing solutions. And they account public-private partnerships of 26 partners. The region, of course, is part of this partnership and is supporting very much all the initiatives. We have more than 700 companies involved so far in the activities and 20 strategic digital innovation projects. EP for FFG is about setting up a territorial ecosystem to support the digital transformation at regional scale initially, and especially on S3 areas of the region. So there is a strong interconnection between our activities and also the activities of the region. Moreover, we have to mention that digitalization is one of the core activities foreseen in the Next Generation EU Fund, which wants to boost the digitalization and together with the Green Deal and the resiliency to recover from the crisis. Also, I have to mention that IP4FUG is recognized as a regional digital innovation hub and is candidate to become a European digital innovation hub, and it was also mentioned in a recent publication by JRC, where it was accounted among the most active digital innovation hubs in Europe, and this was very good news for us. just to conclude, the opportunity of having IP for FVG can be seen for MIT Seed Fund project, because all the research coming from the collaborations between the regional universities and MIT can boost the digitalization transformation of the regional territory and amplify the impact of the introduction of these technologies into the regional territory. So thank you very much.
Thank you, sir. So, I would like to thank also all the organizers. And since we are over time and there is another session starting at 6 p.m., if there are questions, we can interact outside the room and you can ask a question to the speaker. Thanks a lot for your participation. Good evening.